Hello, teacher. Hello, students. Welcome to today's lesson, which will start our exploration of fluid dynamics. In our last lesson, we defined the terms density, pressure, atmospheric pressure, absolute pressure, and volume. Today, we will be focusing on Bernoulli's principle. Let us begin. First, let us discuss a few concepts. When a liquid flows in parallel layers with no disruption between the layers, the flow is known as a streamline or laminar flow. In laminar flows, air moves with the same speed and the same direction at all times and remains consistent. Velocity and pressure remain constant at every point in the fluid. In turbulent flows, there is disruption between the different layers of fluid. The speed of the fluid at any point is continuously changing in both magnitude and direction. Bernoulli's principle states that as the velocity of fluid increases, the pressure exerted by that fluid decreases. This means a fluid, such as air traveling over the surface of an object, exerts less pressure than if the fluid were still. This principle is an important factor in understanding one of the most interesting phenomena on Earth: flight. Airplanes fly because of Bernoulli's principle. As they take off, air rushes over the top surface of their wings. This reduces the pressure forcing it downward. Because the pressure is still normal beneath the wing, it is pushed upward, carrying the impressive weight of the plane along with it. This image gives us some insight into exactly how this pressure functions. Consider a plane moving along the path of the arrow. An ideal flight path would be along the moving air, where the balance of pressure and overall upward force will create lift. A plane only behaves this way in a laminar flow, since the velocity and pressure remain constant. Students, what would happen if a plane were to fly into a turbulent flow? What are the risks involved? Take a moment to discuss this with another student.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you had some interesting ideas in your discussion. Turbulent flows are unpredictable and consist of circular currents of air that can push on a surface in unexpected ways. If a plane were to hit a turbulent flow, then the balance of pressure and velocity would constantly change. This could create upward pressure at some points, but at other intervals, it will create downward pressure. In other words, the plane will start to shake up and down. The risk is that if the turbulent flow is erratic enough, it could force a plane to land, or even worse, to crash. Thankfully, we are able to identify paths through the sky to reorient our planes to follow along safe laminar flows. Bernoulli's principle applies to more than just flight. Here is an impressive example of laminar flow in water. The ball is swinging in still air, which means the pressure is very high. The fluid flowing from the tap is at a higher velocity and thus maintains a consistent low pressure. When the ball comes in contact with the water, it is pulled into the stream. Like a plane transitioning from still ground to a laminar flow of air, this ping-pong ball has just transitioned from the still air to the low-pressure laminar flow of the tap. Students, can you think of any other examples that demonstrate Bernoulli's principle? Team up in groups of 3 to see if you can do this now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I am sure you came up with some interesting examples. Let us look at some now. A great example of Bernoulli's principle presents itself in baseball. A pitcher sometimes throws a curveball in an attempt to get the ball past the batter on an unexpected trajectory. The pitcher accomplishes this by putting a spin on the ball as it leaves his hand. The spin creates more velocity as the ball moves, meaning the airflow over the ball is creating less pressure than underneath. This causes the ball to rise slightly through the air as it approaches the batter. A good curveball is tough to predict. Now, consider a vacuum hose. A vacuum creates changes in air pressure around an object, causing it to lift off the ground and into the laminar flow of the hose. Another example is the flight of a small bird. A bird can glide in a similar fashion to a plane, using its wings to follow a laminar flow of air in a straight line. When a sparrow gains altitude or descends, it flaps its wings at different angles and intervals to control airflow and velocity. This image shows what are called angles of attack. Angles of attack demonstrate the different behavior of air when a wing is angled in a specific way. Students, today we have learned about the Bernoulli principle as well as laminar and turbulent flows. We have also discussed some practical examples of Bernoulli's principle as it presents itself in our daily lives. I hope you have found this lesson informative. Until next time, thank you, teacher. Thank you, students.